Assalamualaikum warahmatullahi wabarakatuh to Professor Mohamad, our chairman for this session. Thank you very much for the kind introduction. And my name is Ashraf, Mohamad Ashraf Mohamad Ismail. I'm a lecturer at School of Civil Engineering, USM. Okay, and today I would like to present part of our work titled Urban Underground Space Geo-informatic System Framework for Sustainable Urban Development in Greater KL. So for this presentation, I would like to give a different overview from what you have heard maybe this morning until now, and also maybe tomorrow, where we discuss a lot about the geospatial information above ground, where we talk about the spatial information for the local council planning, for construction projects, communities, and etc. And just now also, Mr. Tony from MRTC have also explained very good work about the BIM and also some integration of GIS in one of the major projects in Malaysia. And I've mooted this idea also where our country need a very good, what we call the urban underground space geoinformatic system, which is not for this generation, but our future generation for the next 30 or 50 years. So first, let's see why actually we go underground. So we go underground for various conventional and unconventional purposes. For example, like rapid communication routes. And this example shows the Gotthard Base Tunnel that passing through the Alps in order to connect two major cities, where it have cut the transportation routes, the travel time between two countries from a few hours. And we go underground also, for example, like flood hazard, to transfer water from one area to another, either for the raw water or flood water. And this is a very good example and good case study that have been presented, I think, all over the world, which is our smart tunnel. And for example, like we have also a very big project, the Pahang Selangor Water Transfer Tunnel, that have been completed in 2013-2014, where it have been constructed to transfer water from the Pahang to Selangor State in the water scarcity regions. And for example, like in several major developed countries, so there is a lot of the large cavern for underground power station. And this is an example in the Kanagawa, Japan, where they have a very limited also above ground space. They have utilized their underground space for the energy production to put all the turbine and etc. into the deep underground in the mountains. And for example, in some countries, for example in our neighboring countries, in Indonesia, Australia, and other countries, so the underground deep mining is also very popular, where we extract a lot of very valuable and also important minerals for our daily usage. And also for storage facilities. For example, this is one of the world's largest underground LPG storage in Namikata, Japan, which have been developed in order to store liquefied petroleum gas, because as we know that Japan is not importer, not exporter of the energy. So they need to import a lot, and in order to have a good sustainable energy storage, so they built the deep underground storage. And this is also similar to what we have in Singapore, where they have the Jurong rock cavern to install the crude oil. And another example also, in countries that utilize, for example, nuclear waste. So when the nuclear waste have been recycled, reproduced, it will be very highly radioactive, and it need to be disposed very deep underneath. And one of the main solution that have been identified by the geoscientists, engineers, and etc. is actually to put back the nuclear waste into the where we take it from. For example, in this case, there is one underground laboratory in Japan, in the Mizunami, where they have excavate a shaft and also tunnel until 1 kilometer depth. Okay, so we have seen some example on why actually we go underground. But why we go underground in urban area? Okay, For example, we know that nowadays we talk a lot about the livable cities, sustainable development goals in order to have sustainable cities and to provide more urban environment with good quality of life. So in several countries, so they have started to utilize the most valuable space that they have, which is the underground. So several reasons that have been identified, for example, like land use and location. Of course, in major cities, we can see also in Kuala Lumpur, in Singapore, in China, Japan. So the land use in the above ground has become very cramped. And the reason is because isolation. For example, like some structure, you need to isolate it in deep underground. Environmental protection, topographic reason, and also, of course, for some aspect, social benefits. And we take example in these two cases, the use of underground space in Helsinki. So we can see that although the population, the increase of the population is just a little, but the utilization of the urban underground space from 1998 to 2003 have increased quite rapidly. And we can see that the urban underground space volume per person have also increased in Beijing, where the population increase is only from 3.3 to 4.1 population density per kilometer squared. But the use of the urban underground space has been increased quite tremendously. And the trend will keep increasing, not only in these two cities, but I believe also in some other places, for example, also in Kuala Lumpur. So why we go underground in urban area? As we know, for example, like in KL, so there is no choice but to go underground in order to improve our transportation system, like what Mr. Tony have shown to us before. And in Tokyo, for example, we can see that the network of the subway and also the underground transportation is very complicated. We have a tunnel crossing each other, we have a deep underground station, mall, and etc. And in Finland, because in Scandinavian country, the temperature during winter very, very low, so they built underground swimming pool. And also in Norway, they have the Vosjik Olympic Carbon Hall that have been used for the Winter Olympic. And also in Helsinki, they have built also underground church in rocks. So in these countries, the underground space, they are very lucky because they have a very good rocks in order to provide their underground space so they can utilize it a lot for other purpose. And we can see also in cities that have a natural disaster, for example, in Kobe in 1995, so they have a severe damage during the earthquake. We can see that most of the above ground structure have been damaged, for example, like buildings, highway, and etc. But we can say that from the finding, only 90%, most of the 90% of the structure underneath is not affected by earthquake. And this is an example that we can see that there is no damage to underground shopping mall that just located below the City Hall complex in Kobe. And this is another good example where we can see that in France, the situation before the construction of the underground park and also the situation after the construction of underground park. So we can see how we can improve the quality of life in city when we take out the unnecessary above ground structure and put it underneath. And in Malaysia also we have some examples, for example like underground sewerage treatment plant. So Pantai to STP cross section, we can see that how actually we can utilize the above ground space, for example recreation and etc. So what is actually urban underground space geo-informatics? So we have discussed a lot about the above ground space, where we have buildings, infrastructure, road, and etc. But we cannot forget that we also have what we call the very important resources in urban area, which is the underground space. So by utilizing the underground space, so we can make the coexistence between the above ground and underground, and also a smooth interaction between the above ground and also the underground space. So why we need this for KL or Greater KL? We can see that in Tokyo, for example, they have approximately around 63,000 underground areas, including underground pass, subway system, shopping complex, underground passageway, and etc. And around more than 50% of the subway station in Tokyo located underground. And we can see that how complicated it is. This is urban geogrid plan in Tokyo metropolitan to improve the coexistence between above ground and also underground areas by taking the advantage of the underground spaces. And currently in Kuala Lumpur, we have only 14 underground stations from the LRT, and I think 9 from the SSP line, and maybe a lot more from the, SBK, 9 from SBK line, and I think incoming more from the SSP line. And we have a lot of 1,000 unrecorded pile location, pile length data, underground passageway, underground car park, underground utilities, etc. So why it is very important? Because urban underground space provides us huge resource that lies within our feet, and uncoordinated proliferation in underground development ranging from utilities and infrastructure such as tunnels, building and foundation will create also difficulties for the future generation. And when we introduce concrete into the ground, we already put constraint on the future development. So what is the aim? So we should provide those that manage and develop cities with geoscience knowledge, understandings, and tools that will enable them to maximize these important resources, to recognize and manage responsibilities, conflicting demands that will be placed in the subsurface area of our cities, and also to safeguard through the informed stewardship subsurface ecosystem which cities depend, especially in the future. So we can see that it is very important because, for example, like in this hall, we have a lot of professionals like geoscientists, engineers, geospatial, geotechnologists, and etc. So all of these need to collaborate in order to understand how actually we can help each other in order to make important decisions on how actually we're going to develop our urban underground space. And one of the objectives in the framework that I would like to propose is we need to coordinate, to share, and also to inform and empower the policies, especially for the decision maker, for example, like the local council, DBKL, etc. And we make that the subsurface knowledge complementary to the above ground city modeling. We have a lot of examples of the above ground 3D city modeling, but so far I think in Malaysia we don't have any that focus on the underground. So there is two main components of urban underground space geo-informatic system. One is what we call the space subsurface itself. Because above ground we have air, so we can build anything, but underground space, we have the constraint in terms of the subsurface information itself. For example, like the lithology unit, the geological structure, hydrogeological condition, and etc. And we have the urban underground infrastructure information, for example, the utilities, foundation, tunnel, etc. And this is, for example, the data that we need in order to understand what is our subsurface condition. For example, the lithology, stratigraphy, the SPT value, and this is important especially for engineers and geologists to understand before we construct anything inside our subsurface condition. And this is an example of underground infrastructure attributes, the road tunnel, rail tunnel, underground station, underground passageway, pile location, depth, and etc. And this is the current state of urban subsurface knowledge. For example, at this stage, we need to understand what is the existing map, existing data that we have. In addition that it is not enough, we need to capture it, build the knowledge, attribute and predict, and in the end, it will influence decision on how actually we're going to develop it. And this is the example of the urban underground space geo-informatic frameworks in Changzhou, in China, where they have integrated the GIS fundamental platform, where they understand what is on ground, and they also understand what is actually exists underground. So by coexistence between these two information, they will have a very good underground space information database. And this is example, the 3D model of underground infrastructure and surface structure in the Changzhou city in China, where they have all the 3D surface modeling, and at the same time, they also have the subsurface information. So they can easily make it transparent, understand what attribute that they want to look into in order to ensure that there is a smooth transition and coexistence between the above ground ecosystem and also underground ecosystem. And this is actually not enough, where we need also to develop what we call the geological evaluation index, because our underground space is not homogeneous, it is heterogeneous, it is made of the geological material. We need to understand what is the parameters that we need to know, for example, like topography, landform, the engineering geology aspect, hydrogeology, and etc. For example, in Kuala Lumpur, we have a very challenging cast limestone. It is a nightmare for tunneler all over the world. And from this subject level, we can identify what is the index level, the grade, scoring, and etc. And in the end, we can make what we call the underground space construction suitability map. And this is also another example in Changzhou City in China, where they can understand where actually the area that can develop or they have a constraint for future development of the subsurface underground structure. And this is example of the Glasgow 3D subsurface geological modeling. And the model have been used by the town planner, local council to integrate the above ground space development with the available space underground. And they also understand what is the buried infrastructure. And I also know that Jupam also have the PADU, where they incorporate all the utilities, etc. But this is also more concern for more deeper subsurface information. And in Netherlands, for example, like they have what we call the geotop workflow model. And this is also have been used by the town planner, local council to integrate what they know from the above ground and also the underground. And another example, for example, in Oslo, so for the time being, they have all the subsurface information, the borehole data, and etc. They have the pile location, the building information of on ground and also above ground. And this is also helped them a lot in order to understand or to make a decision for future developments. And another example, in Finland, where they have also developed the underground subsurface model, which is also integrated with the 3D surface modeling above ground, where the attributes consist of borehole, pilings, tunnel, underground passageway, and also many other information. So what actually we have in Kuala Lumpur? So for example, in Kuala Lumpur, we have a very challenging geological profile, geological subsurface profile. We have, for example, the cast limestone, Canny Hill Formation, granite, etc. So, of course, we really need to understand how actually this will impact the utilization of our subsurface information. And for example, like the first thing that we need to know that we need to develop what we call the 3D ground information model. I take example, for example, the cost for one borehole drilling, we take it as 8,000 ringgit. Okay? And for the past 30 years, I believe that in KL alone, we have more than 50,000 boreholes. So if 8,000 multiplied by 50,000 boreholes, so actually we are missing a lot, around 400 million worth of data. So you can imagine if we start to collect for the past 30 years until now, so we can already develop 400 million worth of data. But until today, some information kept by other parties, private sector, government. We don't have a sole custodian in order to manage all this information. And this is another example where this is actually from SBK line for UG1. So imagine for one project in MRT alone, I think they have more than 300 borehole data. So every day we can see that a borehole have been drilled somewhere in Kuala Lumpur, but there is no sole agency to take care into it. And if you have a very good, for example, subsurface model, you can really understand. For example, this one, if we want to drill a tunnel passing through this geological information, we can know exactly what kind of material that we will encounter. Either we will have difficulty or not. So this is something that very useful because underground space is very tricky and heterogeneous. So we really need to understand, to have a data in order to have a very good characterization. And another important issue is, like, we have also a lot of existing tunnels, and some have been kept by, for example, Prasarana, and some not. So how actually we can do a mapping for this subsurface information? And this is also by using indoor LiDAR mapping and also photogrammetry in indoor. So we can capture, for example, this is the KLCC station from Ampang to KLCC and also to Kampung Baru. So this kind of information actually can be integrated, okay, into the subsurface modeling and also above ground modeling in order to have a seamless interaction between both information. So what actually urgent action plan that I would like to propose? So currently we need to register current underground infrastructure. For example, like we can see MRTC, they have a very good data. But after the project completed and etc., who will be the custodian of the data? Who will take care of all the information and etc.? And we need to register all subsurface geological model, borehole data, geological structure. And for example, we can improve submission document for CF, where the developer or the client need to submit all the relevant information that are related to the usage of underground space, for example, more than 5 meter depth. Okay, and also we need to identify available current underground space, which owned by private or owned by government. And the most important thing is we need to develop a new portal or platform. Right now we have a lot of platform for above ground, but I think we don't have a integrated portal for the above ground and also underground. And of course, to start with, maybe we can have an idea to set up a national committee, various stakeholders, because it involves a lot of local authorities. When we talk about Greater KL, it's not only DBKL and also MPAJ, other local council, and etc., where we can sit down in order to discuss about this issue. So can we really afford to go underground without vision? So underground space to remain a societal asset, we need to plan to manage it just like any other asset. If this is not done, its greater benefit will prove to be short-lived, and it will eventually cease to be an effective instrumentation for the support, redirection, and also sustainable development of urban areas. And this is conclusion. Although we should start this, I think, 10 years back, but it is still good to have the urban underground space geo-informatic system now, although it should have happened sooner. Okay, that's all. Thank you.